Hello, my name is Emma Gottlieb. I use she, her pronouns, and I work for Quasar Science and Light Panel as a product specialist and technical support sales representative. I am good friends with Assimilate Live Effects, and today I am going to be showing you how to bring in an input capture node into Assimilate Live Effects, and then take that input capture and use that media to drive a Quasar Science fixture. Today we're going to be using a Nintendo Switch as our input capture because I think it's fun to show that you can, sample from a video game you're playing. And then I'm going to be controlling a Quasar Science 2-foot double rainbow. This workflow, in essence, works with any kind of input capture, NDI, SDI, or HDMI. It's just a fun little example and experiment just to show you guys how input capture nodes work. So we're going to play around now. So on the hardware side, as you can see, I have a Quasar Science double rainbow, the 2-foot version. I have my Nintendo Switch, which is going to be feeding an HDMI cable into this HDMI to SDI 3G splitter. I like to add this step, especially when using an HDMI device like a Nintendo Switch, just because I found that converting the signal to SDI before coming into the computer, and then this is the Ultra Studio Recorder 3G coming in through Thunderbolt. That just makes the frame rate and just everything so much cleaner. I haven't had much of an issue with that. And then we are outputting using this TP-Link Ethernet output, an Ethernet cable that's coming into the back of the Quasar Science fixture. So this is the menu of the Quasar Science fixture. I just factory reset it. The fixture needs to be in firmware 0.7b or above. Today we're in firmware 0.8b. And this is the tube just totally factory reset. None of the settings from my previous session with the tube are saved. So I'm going to step to the left and we're going to step into the config menu. And then from the config menu, I always like to keep the DMX channel as 1 because we're going to just assign one universe of data to this fixture today. Number of pixels, this tube can go up to 20 pixels as there's 20 different subdivisions of the fixture. The fixture's output, and we're going to keep that the same. The profile here, this is the first setting we're actually going to change. So we're going to step back to profile 64. And profile 64 is the profile that's going to give you the most image-based lighting control for Assimilate Live Effects. And it's also what we have profiles built for in the software. Next, we're going to step to the right, and we're going to enter the wired settings. Inside the wired settings, we're going to change the protocol to SACN, which is the best protocol for image-based lighting. And then we're just going to give the tube a few seconds to just set the new protocol. Okay. This one always takes a bit. Okay, we're going to step to the right, DMX settings. We're going to skip this, and we're going to go straight to Ethernet settings. We're going to step into Ethernet settings, and we're going to keep the IP address mode as multicast. That's not going to change. The IP address mode here, so this is viewing the IP address the way it's viewed as in multicast, and then the way that we're assigning the IP address. The static means that we're just putting it in manually, but I'm actually going to go to auto DHCP, which just means that it's going to pool its IP address from my computer. And then as you'll see, when it's done thinking, the tube does then, like usually there are IP address settings here and they're all gone. So we're saving the DHCP as static, multicast is enabled, that's good. And universe we're just going to keep as 1. This is our universe 1 tube, so we're going to refer to it as U1. And then that's it. That's our patched tube. So now we can step back by clicking the power button twice, and then we should be able to just patch the tube into Assimilate now. So first things first, we're going to do before we even open Assimilate is we're going to go into our system preferences, and we're going to go to a network, okay? And as I showed you before, the TP-Link Ethernet output Once that's plugged into the Quasar tube and the Quasar tube is plugged in and turned on, then you should get something that looks like this. On PC, it's going to look a little different, but basically what you're going to see is a network that's connected and but is not actually connected to the network. So as you can see right here, the yellow circle shows that the network is connected, but like a green circle would mean that it's connected to the internet. Red circle means that it's not connected at all. So we're a connected network, but we're not connected to the internet, so it's a closed network. That's what we want. This shouldn't look like it's connected to the internet, at least for what we're doing. And then for the purposes of this video, I'm choosing to use multicasting using DHCP. So mine is already set, but if it's set like manually, for example, you can do manual IP addresses. We're not going to do it for the sake of this video and for the sake of brevity. That'll be a whole separate video. So we're just going to go to use DHCP, and that should be that. So now that the tube is set to use DHCP and the computer is set to use DHCP and we have our defined network, then we're all ready to go. So we're going to apply those settings. Now we just need to go and make sure that the capture card is bringing in the correct input. So we're going to go to the desktop video setup application that Blackmagic has conveniently created for us. And as you can see here, our Ultra Studio Recorder 3G has been recognized by the computer because it's plugged in via Thunderbolt. You have to use the Thunderbolt cable. Any old USB-C cable does not do. And then right down here, we can select the video input. So right now we have it set to SDI, which is correct. A lot of the times when I've worked with people who are trying to figure out how to set up their Ultra Studio recorder, they say it's not working. The first thing that I always ask them to do, and it tends to be the issue, like the sort of fault in the workflow, is that they have the Ultra Studio set to HDMI, not SDI, or vice versa. The recorder can only bring in one stream at a time, so it can only listen to one of these inputs at a time. So since we're actually converting the signal from HDMI to SDI, then we're going to keep SDI here, so this is correct. So now that we are all set up with our hardware, our lighting network, and our input capture for our Nintendo Switch, we're going to actually start playing with Assimilate. Assimilate is a great media server that we use for virtual production. I use it specifically more for the cinema world, but I know that it's very helpful for a lot of different sort of avenues of intelligently controlling lights and media with a very simple software interface. So what I'm going to show you today is just really, really basic, but it should give you the building blocks to be able to build something much more complex on top of it. So what I always like to generate first is some filler. I always throw the color bars in just because it's nice to be able to test the quasars, especially when I'm setting up the fixtures, maybe on the shop floor before we start rigging some fixtures, just to make sure they work. Color bars really give you a good sort of rendition of like what exactly is coming through, make sure all the pixels work. And then I also like to throw a black bar, and I like to throw a white bar on the screen, just so I have some options for either blacking out the stage, or some of our color scientist friends might not be too happy with this, but I like to use this white screen just for some basic white light if the scene calls for it. Now if we want to actually bring in the input capture node from the Nintendo Switch, we're going to click on the live setup button here, which lets us create a live input capture node. We click on live setup. We're going to keep it a model basic capture. There's some other options here, but we're not going to play with those right now. And then for the foreground camera, we're going to click here, and we have a bunch of different options. We can do NDI, which is video over Ethernet. We can also do our FaceTime HD camera, which is the camera that it comes with your computer. But today we're actually going to use the Ultra Studio Recorder 3G, which I have my Nintendo Switch plugged into. So as you can see, the second I click on the Ultra Studio 3G, and if we have set everything else up correctly, you should immediately get a preview of the media that you're importing from your outside video source. So now we're going to click Create, and here's our input capture node. If we step back to the construct, you can see that it just shows up as a piece of media on the screen, like the white lines or the color bars. And as you can also see, I'm going to pick up my Joy-Cons now, you can actually scroll through and interact with this just as it's like a TV screen or whatever. So for instructional purposes, I'm going to be using a game called Suika Game just to sort of show how um, the light looks on the fixture and maybe actually do something cool. So next I'm going to step into the Stage Lights tab, and this is where we're actually going to tell. So now we have the video input capture set up. Now we're going to set up the output cast to the fixtures. So we're going to go over to protocols first. We're going to go to SACN because that's the protocol that we're going to be using in the fixture. By default, output multicast is off. We're going to turn that on. And then by default, you're usually set to like EN0 or whatever. And these are your adapters or your native Ethernet ports. We're going to set it to EN8, which is what I already know as my TP-Link adapter, the one that I showed you in the video. And then we're going to have to set a range of universes that are going to be sent down the Ethernet cable. By default, it's just 1 and 1. I like to sort of send it out to 25 universes, even though I'm only using 1 universe of data right now, just in case I ever want to add more fixtures to my setup or whatever. I just have some breathing room, right? So we're going to step away from protocols and we're going to go to fixture now, and we're going to click the import button. Under this import button right here, I've downloaded from the Quasar Science website our Assimilate profiles. These profiles are only for one set of settings currently. It's for profile 64, what I showed you, max pixel mode, and then firmware 7B and 8B. So right now I'm going to click on the Quasar RR50, which is the code for the double rainbow 2-foot, and we're going to click on that, and we're going to open it, and our fixture has generated as an overlay on top of the Nintendo Switch screen. And since my universe in the fixture is universe 1, and it's blinding me already, the fixture is already outputting to the video, or it's already outputting the video. So I'm going to switch over to a handheld capture of what exactly the tube is doing and what's happening on my screen. Okay, so now I actually changed the game to Mario Kart 8 because the Suika game was a little too boring to show through the fixture. Sadly, it just kind of came through as yellow. So I played a quick game and kind of poorly, but I still got first place. So as you can see, the fixture itself, I just pulled off to the side here, and it is dark. But as I bring the fixture into the video, you can see that it populates what it is seeing from the screen. So I have the pixel map for the fixture built out pretty big here, so each pixel area on the tube is sampling from a very large portion. But as you can see, hopefully, and I turn the tube all the way down so you can see it better, but let me turn it up a little bit. As you can see, the tube is responding pretty much one-to-one to what's happening on the screen, and as you move around, and you can resize this, make it as big or as small as you want, and the tube will respond accordingly. As you can see, as I move it around, it's sampling from where it needs to sample from on the screen. And that is how you create a basic input capture node and then output that input capture node to a lighting fixture, in this case, a Quasar Science double rainbow. This process has a lot more steps and a lot more moving parts if you want it to be a little more complicated for a larger virtual production rig, especially if you're using an input capture from something like Unreal Engine or Pixar or whatever. But this is just the basic fundamental building blocks of input capture and output, and hopefully you can do something fun like this at home with maybe a Mario Kart game night or something. This is Emma Gottlieb from Quasar Science, signing off.